Good evening, everyone. So last class we have been discussing questions from thermodynamics, right? And as I've told you already, in this session we'll be discussing questions from equilibrium, that is both from chemical and ionic equilibrium, right? Okay, have you guys revised chemical and ionic equilibrium and all those formulas?
Yes, ma'am.
Okay. So you guys have to be familiar with concepts and formulas as well. Because as far as physical chemistry is concerned, we can expect only problems. So for which formulas are very, very important. So apart from concepts, you have to memorize all those formulas also. Memorizing formulas only will not do. You have to practice lot of numericals. Okay. Fine. So now we'll be discussing questions from both chemical and ionic equilibrium. So as far as chemical equilibrium is concerned, you'll be studying about Kp, Kc, relationship between Kp and Kc and all that, degree of dissociation, and very importantly, Chatelier's principle, reaction quotient and all that. And as far as ionic equilibrium is concerned, you should have studied about electrolytes, strong electrolyte, weak electrolyte, then ionic product of water, then what else? A lot of numericals related to pH, right? Acidic solution, basic solution, hydrolysis of salt, buffer solution, and all that. So relatively, ionic equilibrium will have a lot of concepts and formulas, but relatively chemical equilibrium is little simple. But definitely we can expect questions from both the stuffs, chemical and ionic equilibrium, in which chemical equilibrium is relatively easy. That's it. Okay, shall we start the session? Shall we start the session? Okay, before getting into the question, what is the relationship between Kp and Kc? Both are equilibrium constants, but Kp is nothing but it is the equilibrium constant in terms of pressure, that is partial pressure, and Kc is the equilibrium constant in terms of concentration. And we have to know the relationship between Kp and Kc. What is the formula which relates Kp and Kc?
Kp equal to Kc into RT power del N G.
Del Ng, right. What is del Ng? Ritesh was perfect. What is del Ng?
Number of moles.
Yes, that is n is number of moles, Kana. But what is delta Ng? Delta represents always the difference, right? So delta Ng is number of moles of gaseous product minus number of moles of gaseous reactants. Okay. What is Le Chatelier's principle? What is Le Chatelier's principle? Yes. What is Le Chatelier's principle?
It is when a system in equilibrium is disturbed, it shifts its direction to nullify the effect in the.
Very good. When the system is at equilibrium, and if we disturb the system, that reaction will move either forward or backward to nullify the disturbance. Right? Tatvatika was perfect. How we can disturb the system? The disturbance can be nullified is fine, but how we can disturb the system? By changing the temperature or by changing the pressure or by changing the concentration. So disturbance it can be in terms of temperature, pressure or concentration, right? Fine. So definitely we're going to see questions related to Le Chatelier's principle and all that. Okay, fine. Let us start the session. Okay, the first question is, in a chemical equilibrium, in a chemical reaction, equilibrium is established when? Equilibrium is established when backward and forward reaction ceases, concentration of reactants and products are equal, rate of backward reaction is equal to the rate of forward reaction ceases to generate heat.
Option 3.
Okay. So his answer is option 3. How about Ritesh, Pundamarasi, Marimuthu, Yash, Tatvatika? I'm sorry, Yash is a faculty.
Yash
Sorry,
is a
sorry,
teacher,
sorry,
no? He
sorry.
has come
Sorry,
to
sir.
listen.
Okay.
Yeah, okay, okay.
Yes, ma'am.
Yes, Ritesh, what is your answer?
Option 3, rate of backward reaction equal to forward reaction.
Okay, fine. This is right, but my actual question is I'm going to write three system and I want you guys to tell the difference, okay? What is the difference between these three systems? In three cases, A is a reactant and B is a product. But we can see there is a hell lot of difference between three reactions. What is the difference?
First reaction, only forward reaction take place.
Yes.
One third reaction, it can be forward and backward.
Okay.
And the second reaction, the rate of forward reaction will be increased, but rate of backward reaction will be decreased.
Okay. Very good, Ritesh. Actually, in first system, reactant can get converted into product, but product cannot get converted into a reactant. So only forward reaction is possible. Reverse reaction is impossible. This kind of reaction is called irreversible reaction. But as far as second reaction is concerned, A can get converted into B, that is, a reactant can get converted into product. At the same time, product can also get converted into reactant. Both forward and backward reaction is possible. So this reaction is considered to be a reversible reaction. But the problem is rate of forward reaction is not equal to rate of backward reaction. So this is just a reversible reaction. As far as third reaction is concerned, reactant can get converted into product, product can get converted into reactant. Both the reactions are possible, and the special part is rate of forward reaction is equal to rate of backward reaction. So this reaction is not just a reversible reaction, but also this reaction is considered to be in equilibrium. Okay, so whenever the reaction is said to be at equilibrium, always forward reactions rate will be equal to the rate of backward reaction. Is that clear?
Madam, I have a doubt. This
Yes,
fourth
sir.
option, is this called exothermic reaction? No.
Yes, sir, it is exothermic reaction because
Okay, okay, okay.
exothermic reaction is a reaction in which heat energy will be liberated. Yes.
Yes, okay.
Okay. Second question. The equilibrium constant at 298 Kelvin for a reaction A plus B gives C plus D is 100. We are provided with a chemical reaction whose equilibrium constant is 100. If the initial concentration of all the four species were 1 molar each, then the equilibrium concentration of D will be dash. They're asking us to find the equilibrium concentration of D. So let us take this chemical reaction. 1 mole of A is reacting with 1 mole of B to give 1 mole of C and 1 mole of D. In this reaction, A and B are reactants and C and D are product. Usually, whenever we are doing chemical reaction, we will be starting with the reactant. Usually, we will not have any product. But in this question, they are telling us that they are starting the chemical reaction with product also. So initially, before the chemical reaction starts, A has 1 molarity of concentration, B is 1 molarity of concentration, C and D everything are at 1 molar concentration. Okay, now this reaction is happening. Okay, whenever reaction is happening, reactant will get converted into product. So during the course of the reaction, reactants concentration will get decreased and products concentration will get increased, right? So when the system is at equilibrium, a particular quantity of reactant will get involved in the chemical reaction. So at equilibrium, reactant A's concentration will not be 1 molar. Definitely it will be less than 1. But we don't know how much quantity of A was reacted. So I'm going to write it as 1 minus X quantity was the remaining concentration of A. How about B? Again, that is also 1 minus X. How about C and D? What will be the concentration of C and D?
0, ma'am.
No. Initially, we have started with a particular concentration of C and D, which is 1 molar, right? Whenever chemical reaction is happening, the concentration of reactant will get decreased and concentration of product will get, yes, Ritesh?
1 plus X.
Very good. So whenever reaction is happening or whenever chemical reaction is occurring, reactants concentration will get decreased and products concentration will get increased. Now at equilibrium, concentration of C and D will be greater than 1 because initially itself it was 1 molar. Now it will be greater than 1. Here X quantity was reacted. So here X quantity would have been produced. So the concentration of C at equilibrium is 1 plus X and the concentration of D at equilibrium is also 1 plus X. See, whenever you're writing this X, we have to be very, very careful. So we have to see the stoichiometry of the reaction. Here I have 1 mole of A is reacting with 1 mole of B. That is why I've written like 1 minus 1x. 1 minus 1x. Here also 1 mole of C is formed and 1 mole of D is formed. That is why this is 1 plus x and this is 1 plus x. For example, I'm going to give you another example. What is Haber's process? What is Haber's process? What is Haber's process? Preparation of ammonia from?
From Kp and Kc.
No. What is Haber's process? Haber's process is nothing but nitrogen and hydrogen will get combined together to give ammonia. Okay. Please balance this equation. Left side I have 2 moles of nitrogen. Right side I have only 1 mole of nitrogen. So I have to write 2 here. Now left side I have 2 moles of hydrogen. Right side I have 6 moles of hydrogen. So I have to write 3 here. So preparation of ammonia from hydrogen and nitrogen is called Haber's process. Okay. For example, at time t is equal to 0, the initial quantity of hydrogen is considered to be A and initial quantity of nitrogen is considered to be B. When time is 0, that is before the chemical reaction is occurring, there will not be any product formed. So the concentration of ammonia at time t is equal to 0 is, time t is equal to 0 is 0 because ammonia would have not formed at all. Okay. When the system is at equilibrium, what happens? A particular quantity of hydrogen would have got involved in chemical reaction. Similarly for nitrogen. But we don't know how much quantity of hydrogen and nitrogen was involved in chemical reaction. So to write the general term, how we have to write is initial quantity minus quantity of hydrogen involved in chemical reaction, right? So it is not just X. What is the stoichiometry here? 3 moles of hydrogen was involved. So here I have to write it as A minus 3x. How about nitrogen? Here 1 mole of nitrogen was involved. So initial quantity was B minus how much X was reacted? Here the number of moles of nitrogen is just 1. So how many X was reacted? Only 1x, right? So the remaining concentration of hydrogen is A minus 3x and remaining concentration of nitrogen is B minus 3x. And how much quantity of ammonia was formed? It is not just X. How much quantity of ammonia was formed? What is the stoichiometry or what is the number of moles of ammonia? What is the number of moles of ammonia?
2, ma'am.
So, quantity of ammonia would have formed? It is 2x. So, whenever you're writing this concentration, concentration, please make sure you're writing the proper number of X here. In this question, we need not worry because the number of moles of reactants was 1 and number of moles of product was 1. So I've just written like 1 minus X, 1 minus X, and this is 1 plus X, 1 plus X. Fine. So now we'll come back to this question. What is the equilibrium constant? Kc is nothing but concentration of product divided by concentration of reactant at equilibrium. So here products are C and D. So concentration of products is divided by concentration of reactant. So all the number of moles were 1. So C power 1, D power 1, A power 1 and B power 1. So at equilibrium, what is the concentration of C? 1 plus X. At equilibrium, what is the concentration of X? What is the concentration of D? It is 1 plus X. And at equilibrium, concentration of A and B. What is the concentration of A and B? At equilibrium,
X minus 1 into X minus 1.
1 minus X. 1 minus X and 1 minus X. It is not X minus 1. Okay. What is the value of Kc? Are we provided with the value of Kc?
100.
Very good. It is 100. Actually, what is the purpose of this question? We have to find the concentration of D at equilibrium. So what is the concentration of D at equilibrium? It is 1 plus X. So basically, we have to find the value of X. So we have a proper relationship here. So using this relationship, we have to find the value of X and we have to substitute it 1 plus X. Simplifying this is very easy. You need not do a complex calculation. See, left side is 100. Right side, this is 1 plus X into 1 plus X. Denominator, it is 1 minus X into 1 minus X. So both the side take a square root. So square root of 100 is 10. So right side, it is only 1 plus X and 1 minus X. That's it. Please simplify this and find the value of X. After finding the value of X, substitute here and find the value of concentration of D at equilibrium. Definitely, it is going to be greater than 1. So obviously, option A and D were ruled out. So among B and C, we have to find the value. So please simplify and tell me the value of X. So you just have to cross multiply it and please simplify and tell the value of X. Ratish, what is the value of X?
I am solving.
Okay, Kana. Maributtu? You got the value of X?
Yes, 9 by 11.
Yes, 9 by 11. Yes, Maributtu?
Yes, the answer will be B.
Yes. So Ratish, Marimuthu and Tatvatika's answer was right. Answer is?
Option B.
Option
B, ma'am.
Okay. What is the value of X?
9 by 11.
9 by 11. Okay. So if it is 9 by 11, then what will be the value of 1 plus X? Is it 9 by 11?
Yes,
Everybody
ma'am.
got 9 by 11, right? Okay. What is 9 by 11?
From the value of X.
Just divide and tell me, that's it. Or please substitute in 1 plus X, and what is the value of 1 plus X? It is 1.181. 1.818, right? So answer is second option. So now, shall we move on to next question? Do you have any doubt?
No, ma'am.
Okay, now second question is for a reversible reaction. Okay, here the symbol is equilibrium symbol, so the reaction is considered to be at equilibrium. Nitrogen plus hydrogen gives ammonia plus heat. Now tell me, is it exothermic or endothermic reaction?
Exothermic reaction.
Yes, because here heat energy is liberated, so this reaction is considered to be exothermic one. Okay, the equilibrium shifts in forward direction when by increasing the concentration of ammonia, by decreasing the pressure, by decreasing the concentration of nitrogen and hydrogen, or by increasing pressure and decreasing temperature. So this question is basically from Le Chatelier's principle. Now we have to shift the equilibrium in forward direction. So to shift this equilibrium in forward direction, what we have to do? Whether we have to increase the concentration or decrease the pressure, or we have to decrease the temperature or decrease the concentration of the reactants. So what is the essence of Le Chatelier's principle? Initially you told me the definition of Le Chatelier's principle. So we'll see how to solve this kind of question. See, whenever the system is at equilibrium, we can disturb the system in terms of temperature, pressure, or concentration. But that disturbance can be nullified by the reaction either by shifting in forward or reverse direction. Okay. So if the disturbance is in terms of temperature, then if you increase the temperature, reaction will move towards endothermic reaction. If you decrease the temperature, then reaction will move towards exothermic reaction. This is in terms of temperature. If you increase the pressure, how we can increase the pressure? Generally, how to increase the pressure? I have a cylinder full of gas and this cylinder was closed using a frictionless piston. So how to increase the pressure?
By adding heat.
No.
By reducing the volume, by compressing.
Yes, by compressing, because the cylinder is closed with a frictionless piston where volume can be adjusted. Okay, so I can increase the pressure by decreasing the volume. So if I increase the pressure, reaction will move towards the side where gaseous number of moles are less. If I decrease the pressure by increasing the volume, then reaction will move towards the direction where gaseous number of moles is more. Okay, this is in terms of pressure. Next, if you increase the concentration of the reactant, then reaction will move towards forward direction. Or I can decrease the concentration of product either by decreasing the concentration of the product or by increasing the concentration of the reactant. I can make the reaction to shift towards forward direction, or I can increase the concentration of product or I can decrease the concentration of the reactant. So the reaction will move towards reverse direction, right, backward. Now what they asked us to find, we have to shift the equilibrium in forward direction and this reaction is exothermic. So now tell me the answer. We have to shift the equilibrium in forward direction. So what is this forward reaction? This is exothermic reaction. So to move the reaction towards exothermic direction, what we have to do? What we have to do? We have to decrease the temperature. So what must be the answer? What must be the answer? we have to decrease the temperature. That is point number one. How about pressure? Left side, I have 4
I'm,
moles of, yes, Ratish?
I'm increasing, sir.
Yes, we have to increase the pressure and decrease the temperature. If I decrease the temperature, the reaction will move towards exothermic one. And another one is I can increase the pressure, because whenever we are increasing the pressure, reaction will move towards the direction where gaseous number of moles is less. So as far as this reaction is concerned, left side I have 1 mole of nitrogen gas and 3 moles of hydrogen gas. So totally I have 4 moles of gaseous species at the reactant side. How about in product side? I have 2 moles. So where the number of moles is less? At the right side. So if you increase the pressure, reaction will move towards forward direction. So by increasing the pressure and decreasing the temperature, I can shift this equilibrium towards forward direction. Is that clear? Fine. Now we'll move on to next question. For a given exothermic reaction, Kp and Kp prime are the equilibrium constants at temperature T1 and T2 respectively. T2 is greater than T1. And now we have to find the relationship between Kp and Kp prime. So you have to know for exothermic reaction, if we increase the temperature, what will happen? What will happen to the value of Kp? So please imagine that and tell me the relationship between Kp and Kp prime. If you want time, I'll give. Or you want the answer, then I'll give the explanation. Pundamararasi, are you working out?
Yes, ma'am.
So I have a chemical reaction where A is the reactant and B is the product. And this reaction is at equilibrium. And this reaction is happening at the temperature T1. And for this reaction, the equilibrium constant is Kp. This same reaction is occurring at T2 temperature, and for this reaction, equilibrium constant is Kp prime. Whenever you're changing the temperature, definitely equilibrium constant's value will change. Equilibrium constant is dependent only on the temperature. If you change the temperature, either you increase the temperature or decrease the temperature, definitely Kp value will change. And equilibrium constant will not depend on any other parameter. Equilibrium constant depends only on the temperature, not on the concentration, not on the volume, not on the pressure. Equilibrium constant depends only on the temperature. And Tatvatika's answer is option A. We'll check Tatvatika. See, as far as exothermic reaction is concerned, if you increase the temperature, will make the reaction favorable? No. Because what is exothermic reaction? Whenever reaction is happening, heat energy is getting liberated out. So for such kind of reaction, heat energy is not required. So if you increase the temperature, then definitely we are disturbing the system. So what is Kp? It is the pressure of product divided by pressure of reactant, right? So if you increase the temperature, reaction is getting disturbed, due to which product will not occur. So concentration or the pressure of B will get decreased and pressure of reactant will get increased. So if you increase the temperature for exothermic reaction, reaction is getting disturbed and forward reaction will not occur freely. So due to which product's concentration or the pressure of the product is getting decreased. So if the numerator is low and if the denominator is high, then what will happen to Kp prime? Kp prime will be, the value of Kp prime will get reduced. So Kp is always greater than Kp prime for this kind of reaction. Is that clear? But if the reaction is endothermic, then if you increase the temperature, then Kp prime will be greater than Kp. Right? So nature of this reaction is very important. So according to this question, the reaction is exothermic reaction. So we need not give temperature, we need not increase the temperature to increase the concentration of the product. Is that clear? Yes. So Marimuthu's answer and Tatvatika's answer was perfect. So shall we move on to next question?
Yes, ma'am.
Fine. So next question is, which of the following statement is not correct? The value of equilibrium constant is changed in the presence of catalyst in the reaction at equilibrium. Enzymes, enzymes catalyze mainly biochemical reaction. Coenzymes increases the catalytic activity of enzyme. Catalyst does not initiate any reaction. We have to find the right statement. I mean, we have to find the wrong statement. They're asking us to find the wrong statement. What is option D? Catalyst does not initiate any reaction. Is that statement true or false?
It is true, ma'am.
True. Catalyst cannot initiate any chemical reaction. So that statement is true. So that is not going to be our answer. Fine.
Ma'am, option
Coenzymes.
A.
Yes, Marimuthu's answer is option A, and it is right because the statement is equilibrium constant is changed in the presence of catalyst, but actually it is not true. Just now I've told you equilibrium constant depends only on the temperature and not on any other parameter. But the statement is equilibrium constant can be changed in the presence of catalyst, which is absolutely wrong. So the answer is option A, which is a wrong statement. This question. This is also a neat question. We are provided with three reactions, and each reaction's equilibrium constants are K1, K2, and K3 respectively. And we are provided with another reaction for which we can have equilibrium constant as K prime. Now we have to find the relationship between K1, K2, and K3 to find the value or representation of K prime. We have to write the equilibrium constant for this reaction in terms of K1, K2, and K3, which is very, very easy question. It is a neat question. If you want clue, I'll give you. Who want clue? Ratish, do you want clue? Vijay Kumar?
No, ma'am, I'm solving, ma'am.
Okay, fine. I'll give you 30 seconds. Please solve. Marimuthu, are you solving or do you
Yes,
want
ma'am.
clue? Do you want clue, Marimuthu?
Yes, ma'am.
Okay. Actually, we have to write the representation of K1, K2, K3. And also you have to write the representation of K prime. After writing K prime, we can understand how this K1, K2, K3 can be adjusted or can be written to come up with the representation of K prime. So first write the equilibrium constant expression for all those four reactions. So what is K1? Concentration of product divided by reactant. So concentration of product is AB3 power 2 divided by concentration of the reactant is A2 and B2, and the number of moles of B2 is K1, right? And what is K2? Concentration of product, which is AC. And what is the number of moles of AC? 2. So I have to write the number 2 in the power divided by concentration of A2 and concentration of C2. And how about K3? Can anyone tell me the representation of K3? So please tell me the expression for K3. Concentration of product divided by reactant. So what is the product in third equation?
Concentration of B2C divided by concentration of B2 plus, sorry ma'am, uh, C2 power 1 by 2 or root C2.
That's it. So this is the expression for K3. Now we have to write the expression for this reaction. So I'm going to represent this equilibrium constant as K prime. And what is the expression? Concentration of AC power 2, concentration of B2C power 3 divided by concentration of AB3 power 2 and concentration of C2 power 5 by 2. So we have to write the proper relationship between K1, K2 and K3 to come up with the expression of K prime. So in this K prime, B2C in the B2C is present in the numerator. Among K1, K2, K3, in K3, B2C in the numerator. So definitely K3 will be at the numerator, right? So K3 has to be in the numerator. So in the option, in first option and in fourth option, okay, in first option, definitely K3 is not in the numerator. So first option is ruled out. And what is second one? AC has to be in the numerator. Where we have AC's part in K2. So AC square has to be in the numerator. So K2 has to be in the numerator, right? So K3 and K2 has to be in the numerator. So which are all the options were ruled out? In K prime, AC power 2 and in K2 also AC power 2. So we need not do anything for K2. But as far as K3 is concerned, in the numerator we should have B2C power 3. But in K3 we just have B2C. So we have to cube this K3. So this should be the numerator, right? So which will be the right option then?
Option 3.
That's it. That's it. Okay, fine. Do you have any doubt? Shall we move on to next question? Okay. So next question is, consider the given reaction. 3 moles of A, 1 mole of B is mixture. If a mixture of 2 moles of each of A, B, C exists at equilibrium and Kc is 9, Then they're asking us to find the volume of the flask. So I'm going to write this equation. 3 moles of A, 1 mole of B reacts together to give 2 moles of C, and this reaction is at equilibrium. And when the system is at equilibrium, number of moles of A is 2, number of moles of B is also 2, and number of moles of C is also 2. So 2 moles of A was present at equilibrium, 2 moles of B was present at equilibrium, and 2 moles of C was also present at equilibrium. Okay. And they're asking us to find the volume of the flask. We have to find the value of V. And we are provided with the value of Kc, that is equilibrium constant. In terms of concentration is 9. Okay. What is Kc? Basically, what is Kc? Concentration of product divided by concentration of the reactant. Right? Do you have any doubt in writing the expression of Kc? Concentration of the product divided by concentration of the reactant. But whenever you're writing the concentration term to its power, we have to write the number of moles of A, B, and C. Right? Fine. So what is concentration basically? What is the expression for concentration? Concentration is equal to number of moles by volume. So Kc is equal to concentration of C is nothing but number of moles of C divided by volume of the flask, the whole square, divided by number of moles of A divided by volume of the flask, whole power 3, number of moles of B divided by volume of the flask. Right? All these number of moles were at equilibrium, right? Okay. What is the value of Kc? Are we provided with the value of Kc? Are we provided with the value of Kc? Yes, right. What is the value of Kc?
Yes, ma'am.
9.
9.
9.
So left side we have 9. And what is the number of moles of C at equilibrium? It is 2. So 2 by V the whole square divided by 2 by V whole cube, 2 by V. Just simplifying this, we can find the value of V, that is volume of the flask. Please simplify and come up with the value of V. Tatvatika, your answer is second option, right? 6 letters. Right, Tatvatika?
Yes, ma'am.
Okay, fine. How about rest of the students? Okay, Marimuthu's answer is also second option. So let us check. Ritesh, have you calculated?
Yes, ma'am. I am dividing the last value.
Okay, do it. Pundamadarsi, what is your answer? So answer is 6 liters. Tatvatika and Marimuthu's answer was right. What is your value, Ritesh?
Yes, ma'am. 6, ma'am. 2 by
Okay.
0.33 gives 6.
Okay. Pundamadarsi? Pundamadarsi?
Ma'am, 6, ma'am.
Okay, Kanna. Shall we move on to next question then? Fine.
Yes, ma'am.
Okay. So consider the reaction. 2 moles of A is reacting with 1 mole of B to give 2 moles of C, for which Kc is given as 350. If 0.001 mole of each of the reactants and product are mixed in 2-liter flask, then the reaction quotient at the reaction quotient and the spontaneous direction of the system will be dash. Here they're asking for two questions. One is they're asking us to find the equilibrium reaction quotient And also we have to find the spontaneous direction of the system, whether the reaction is shifting towards left or right. So what is the difference between Kc and Qc? Qc is your reaction quotient. So what is the difference between Kc and Qc? Expression will be same for equilibrium constant and reaction quotient, but the logic is different, right? So Kc is nothing but concentration of product divided by reactant at equilibrium, right? Qc is nothing but concentration of product and divided by reactant at non-equilibrium. So by comparing the value of Kc and Qc, we can find the direction of the reaction. If Qc is less than Kc, then reaction is moving towards forward direction. If Qc is equal to Kc, then the reaction is at equilibrium. If Qc is greater than Kc, then reaction is moving in backward direction. That's it. So first find the value of Qc. So the expression is nothing but concentration of product divided by the concentration of reactants. Here we have number of moles and the volume. So concentration is very simple. Number of moles by volume is the concentration. We are provided with number of moles and the volume. Please substitute here and find the value of Qc. And from the value of Qc, we can screen the options, and from the screened option, find the original answer. Once you found the value of Qc, you can compare it with Kc, which is already provided, which is 350. So from by comparing Qc and Kc, we can find the direction of the reaction.
Option 4 and the correct.
Okay, option
4. QC equal to 2000.
Okay, so Qc is equal to 2000. So definitely it is the answer is not going to be option A and C. So if Qc is 2000, then please compare it with Kc. Two thousand is greater than 350. So reaction is moving in which direction? Forward or backward? Okay. Yes, Ratish.
Yes, ma'am, back.
Backward. So the reaction shifts to left. So Tatvatika's answer was right. Answer is second option. Do you have any doubt? Marimuthu Pundamararasi?
No, ma'am.
Okay. Now we'll move on to next question. When a sugar is dissolved continuously into a fixed volume of water at room temperature, a stage comes when no more sugar dissolves. Instead, it settles down at the bottom. The solution is now said to be dash. Okay. So now the solution is said to be saturated solution. Whenever the system is at saturation, that system is at equilibrium, right? So answer is both 2 and 3. Okay. Shall we move on to next question? Right. Here, when 3 moles of A and 1 mole of B are mixed in 1 liter vessel, the following reaction takes place. A and B reacts together to give C. And they're asking us to find, okay, the equilibrium mixture contains, zero point 0.5 mole of C. So what is the 0.5 mole? The equilibrium concentration of C. When the system is at equilibrium, the concentration of or the number of moles of C is 0.5. What is the value of equilibrium constant for this reaction? They are asking us to find the equilibrium constant, which is very simple, Kc. So for which we have to find the value of equilibrium concentration of A and B. C is already provided. So we have to find the value of A and B, and please substitute in that expression, simplify and come up with the value. I'll give you 1 minute for this question. After 1 minute, if you want any clue, please let me know. I'll give you a clue. Or we'll do it together. After 1 minute, please let me know. Okay. Ratish, Marimuthu, Tatvatika, do you want clue? Or shall we work out together? Or you guys working out already? Shall we work out together? Marimuthu?
Yes, ma'am.
Okay, fine. So, what is the given reaction? A plus B, that is 1 mole of A is reacting with 1 mole of B to give 2 moles of C. So,
Option A.
option A. Okay, we'll check Ritesh. Okay. Initially, what is the number of moles of A? It is 3 mole. What is the number of moles of B? It is 1 mole. And quantity of C will be 0 because reaction is not started yet. Okay, when the system is at equilibrium, we know from 3 moles of A, a particular quantity would have been reacted. So, how much quantity? It is just X because this is 1 mole. So, this is 1X. This is 1 minus 1X. How much quantity would have formed? 2X quantity of C would have been formed. And what is this quantity? 2X is given as zero point 0.5, or 2x can be written as 1 by 2. So what is the value of x? It is 1 by 4. That's it. So they are asking us to find the value of Kc. What is Kc? Concentration of C power 2 divided by concentration of A into concentration of B. What is concentration? Number of moles of C, which is 0.5, divided by volume of the solution, volume of the container, which is 1 whole square, divided by what is the number of moles of A at equilibrium? Actually, it was 3 mole. Initially, it was 3 mole. And what is the value of X? It is 1 by 4. This is the number of moles of A at equilibrium. And 1 minus 1 by 4 is the number of moles of B at equilibrium. So find the number of moles at equilibrium for both A and B and substitute here. Number of moles of A divided by 1 liter into number of moles of B at equilibrium divided by 1 liter. And left side we have, left side we have to find the Kc. So it is 1 liter. So all the thing will get cancelled out. And what will be the value of Kc? Ritesh answer is 0.12. Answer is right. Shall we move on to next question? Okay, fine. Now the next question is, at 700 Kelvin, the equilibrium constant Kp for the reaction is 1.8 into 10 power minus 3 atmosphere. Okay. They're asking us to find the value of Kc for the above reaction at the same temperature in mole per liter. See, if the temperature is same, see, equilibrium constant will change only if you change the temperature. Okay. So if Kp is 1.8 into 10 power minus 3 atmosphere, then what would be the value of Kc? It is a very direct question. We have to use the relationship between Kp and Kc. That's it. What is the relationship between Kp and Kc? Kp is equal to Kc into RT power delta Ng. Here you have to use the value of R in terms of atmosphere. So R is equal to 0.0821 liter atmosphere per mole per Kelvin. So you have to use the value of R as 0.0821 liter atmosphere per mole per Kelvin. So you can find the value of delta Ng. Please substitute it and come up with the value of Kc. What is the answer? So Kp divided by RT power delta Ng is equal to Kc. What is Kp? 1.8 into 10 power minus 3 divided by RT power delta Ng is number of moles of gaseous product is 2 plus 1 3 minus number of moles of gaseous reactant is 2. So delta Ng is equal to 1. That's it. This is Kc. So 1.8 into 10 power minus 3 divided by, so the unit is atmosphere, and value of R is 0.0821 liter atmosphere per mole per Kelvin. And what is the temperature? 700 Kelvin. So Kelvin per Kelvin will get cancelled out. Atmosphere and atmosphere will get cancelled out. So 1.8 into 10 power minus 3 divided by 0.08 divided by, here I have liter, right? Liter per mole, and I have 700 Kelvin, that is 7 into 10 power 2. So if I take this 10 power 2 to the numerator, it will be 10 power minus 2. So 10 power minus 3 and 10 power minus 2 will be 10 power minus 5. So please simplify and come up with the value. Tatsutika, can you please check it once again?
Option B.
Okay. Answer is second option. Okay. Shall we move on to next question? Okay. This question is from ionic equilibrium. We have discussed 10 questions from chemical equilibrium. Now we're going to discuss questions from ionic equilibrium. The concentration of hydrogen ion in a sample of soft drink is 3.8 into 10 power minus 3 molarity. What is its pH? They're asking us to find the value of pH, and we are provided with the value of concentration of H plus. We have a direct formula to calculate pH from the concentration of H plus ion. What is the formula? What is the formula? What is the formula to calculate pH? Using H plus ion concentration?
So minus log H plus ion.
That's it. So pH is equal to minus log of H plus ion concentration. See, finding log value is very easy, right? Finding log, anti-log values are very, very easy. Okay, first we'll work out this question, and after which I'll tell you how to find the log values and anti-log values. I think we would have discussed it already, but again, we'll discuss, okay? Or shall we see how to find the log values and anti-log values first? Okay. So what is the concentration of H plus ion here? What is the value of H plus ion concentration?
3.8 into 10 power minus 3, ma'am.
Yes, 3.8 into 10 power minus 3. See, here it is like log A into B. So log A into B can be written as, I'm going to take this minus as common. So log A plus log B. That's it. So minus of log 3.8. This is like log A power B. Log A power B can be written as B log A. So this minus 3 which is present in the power will come in front of log 10. Right. What is the value of log 10?
1, ma'am.
1. So 3 into 1 is 3. I'm going to multiply throughout minus. So minus log 3.8 minus into minus plus 3. So what should be the value of pH? 3 minus log 3.8. Definitely pH value must be less than 3. Right. So what will be the answer then? What will be the answer?
Option C, ma'am,
That's it.
2.2.
Very good. It should be 2.42. Okay. Or we can calculate the value of pH very exactly. Have to calculate that. See. So whenever you are doing this problems using log, you have to memorize these values. Log value of 2 is 0.3010. Value of log 3 is 0.4771. Value of log 5 is 0.6989 and log 7 is 0.8450. We need only these four log values. Okay. So we have to find the value of log 3.8. See, value of log 2 is 0.3. Log 3 is 0.4771. Value is getting increased from log 2 to log 3. Similarly, log 5 is 0.6989. The value is greater than log 3, right? So where should be 3.8? Somewhere between log 3 and log 5, right? So value must be between 0.4771 to 0.6989. So randomly choose a value. In fact, you can find the value of log 4. What is log 4? Log 4 can be written as log 2 square. So what is log 2 square? I mean 2 log 2. We know the value of log 2 as 0.3010. So without memorizing, we can write the value of log 4 as 0.6020. So randomly we can find the value of log 3.8. Please tell me the value of log 3.8. Any approximate value between 0.4771 and 0.6020. Any random value will do. Yes. Any random value between 0.4771 and 0.6020.
0.501.
Okay, 0.50. So what is the answer? 3 minus 0.5 is 2.5. Approximately we got the answer. Right. Shall we move on to next question? Okay. The pH of a sample of vinegar is 3.76. So we are provided with the value of pH and they're asking us to find the concentration of H plus ion concentration. So opposite to the last question. So in last question, we are provided with H plus ion concentration and they asked us to find the value of pH. Now we are provided with pH and we have to find the concentration of H plus ion concentration. So pH is equal to minus log of H plus ion concentration. What is pH? 3.76, which is equal to minus log H plus ion concentration. So throughout I'm going to multiply it with minus. So log of H plus ion concentration is equal to minus 3.76. So what is H plus ion concentration? I have to bring this log to right hand side. So it can be like 10 power minus 3.76. But we have to simplify those values, right? Because the option is quite different. So I can write it like this and we have to find the value of this. Or another idea is H plus ion concentration is equal to anti-log of minus 3.76, right? Now we have to find the anti-log of minus 3.76. So without using calculator and without using log book, we can find the anti-log of this minus 3.76. To find this anti-log, please follow the steps what I'm going to teach you now. Please guys listen. Anti-log, I'm going to write it as A. I'm going to split this minus 3.76. How I can split minus 3 minus 7, 0.76. The value before decimal point and the value after decimal point. I'm going to split like this. Whenever you're splitting, you have to make sure that there should not be any negative sign before this decimal number. So how to remove this negative sign? It is very easy. You have to add minus 1 and plus 1 and simplify this minus 0.76 with plus 1. So minus 3 and minus 1 will be minus 4. So plus 1 and minus 0.76 will be, subtract those values and tell me. 1 minus 0.76 will be plus 0.24, right? Tatvatika, am I right?
Yes, ma'am.
Yes. The next step should be I have to write this minus 4 in terms of log and I have to write this 0.24 in terms of log. Writing minus 4 in terms of log is very easy. Have to write log 10 power minus 4. So what is the value of log 10 power minus 4? That will be minus 4 log 10. Log 10 value is 1. So it is obviously minus 4 into 1 is minus 4. So what I've written is right. Minus 4 can be written as log 10 power minus 4. Similarly, I have to write this 0.24 in terms of log. How should I write that? If the value was 0.3010, I can write it in terms of log as log 2. If the value was 0.4771, I can write it as log 3. If the value is 0.6989, I can write it as log 5. Here the value is 0.24. So where the 0.24 will be? Before log 2. What is the value of log 1? It is 0. So 0.24 will be somewhere between 1 and 2. Randomly, please come up with the value between 1 and 2. Log 1 point something. I can write it as, yes, any value between 1 and 2. Yes, Satsvatika?
Log 1.3.
Okay, fine, 1.3. Now, this is like log A plus B. So, I can write it as log A into B. Log and anti-log will get cancelled out. So, what will be the concentration of H plus ion? 1.3 into 10 power minus 4. So, what is the answer? Approximately 10 power minus 4 must be the answer. So, option C is ruled out. So, what is the nearest value? Option A. Is that clear? Is that clear? Fine.
Yes, ma'am.
Right. See here, we got negative sign in front of this decimal number. That is why I've added -1 and +1. If there is a positive sign, then you can skip this step. Okay, for example, this is minus 3.76. No, for example, see, if we want to find the antilog of 3.76, this is easy. We can step that particular step. How to find antilog of, I have to split this number. So how I can split 3 plus 0.76. So here there is a positive sign in front of a decimal number. So I need not add -1 and +1. I can directly go to the log step. So I have to write this 3 in terms of log. So log 10 power 3. And I have to write this 0.76 in terms of log. How I can write log 5 is 0.6989 and log 7 is 0.8450. So value is 0.76. So value must be between 5 and 6, right? So log, I can choose randomly between 5 and 6. So log 5.3 or something. So I can write it as log 5.3 into 10 power 3. Log and antilog will get cancelled out. So what will be the value? 5.3 into 10 power 3. As simple as that. Is that clear? Is that clear? Shall we move on to next question? Okay. Assuming complete dissociation, calculate the pH of 0.03 molar HCl and 0.05 molar sodium hydroxide. See, the previous question was we are provided with H plus ion concentration. From H plus ion concentration, we have to find the pH. But in this question, we are provided with the concentration of acid as far as this question is concerned. We are provided with the concentration of acid from which we have to find the concentration of H plus and from which we have to calculate the value of pH. So they have mentioned like hydrochloric acid will get dissociated completely. So HCl dissociated to H plus and Cl minus ion. So concentration of hydrochloric acid was 0.03. Upon complete dissociation, H plus ion concentration will also be 0.03 and Cl minus ions concentration will also be 0.03 and there will not be any undissociated HCl. So H plus ion concentration is 0.03. So from which we can calculate the value of pH. So similarly, sodium hydroxide is a strong base. Upon complete dissociation, we'll end up with Na plus and OH minus ion. So the concentration of sodium hydroxide was 0.05. Upon complete dissociation, OH minus ions concentration is 0.05. So from which we can calculate the value of pOH. So what is the value of pOH? Minus log of OH minus ion concentration. So after finding pOH, we have a relationship between pH and pOH. pH plus pOH is equal to what? pH plus pOH is equal to?
14, ma'am.
Very good, 14. So from this, you would have calculated the value of pOH. So from the value of pOH, find the value of pH for sodium hydroxide. That's it. So find the value of pH of HCl and sodium hydroxide.
Option A, ma'am.
Very good. Yes. See, as far as hydrochloric acid is concerned, the concentration of the acid and concentration of H plus was equal. As far as sodium hydroxide is concerned, the concentration of sodium hydroxide and concentration of OH minus ions were equal. But if the acid is sulfuric acid and the concentration of acid was 0.03, then what will be the concentration of H plus ion? They not be equal.
6, ma'am.
Yes, It is 2 times the concentration of acid because each sulfuric acid will release 2H plus ion. Similarly, if the base is calcium hydroxide, then if the concentration of calcium hydroxide is 0.05, then what will be the concentration of OH minus ion? Each calcium hydroxide will release 2 times of OH minus ion. So 2 into 0.05. So you have to be very conscious in finding the concentration of H plus and OH minus ion. Fine. Now we'll move on to 15th question. This is also another interesting question. 0.3 gram of calcium hydroxide dissolved in water to give 500 ml of solution. They're asking us to find the pH of the solution. See, for the reference, I've given you the log values plus, but please, you have to memorize the values, okay? You have to memorize the value of log 2, log 3, log 5, and log 7. Very simple. By using this 4 log values, you can do log, anti-log, and all that, okay? Plus, but you have to memorize it, okay? So the solute is calcium hydroxide. So they have taken 0.3 gram of calcium hydroxide and they're dissolved in water to give 500 ml of solution, and they're asking us to find the pH of the solution. Now tell me, will the pH be less than 7 or greater than 7? Will it be less than 7 or greater than 7? Will the solution be acidic or basic? Will it be acidic or basic? Calcium hydroxide is an acid or base?
Base, ma'am.
Base. Then the pH will be greater than 7, right? So obviously first option is ruled out. Okay. So first, last time we are provided with the concentration of H plus. And in next problem, we are provided with the concentration of acid or concentration of base from which we have calculated H plus ion and OH minus ion's concentration. In this case, we are not provided with the concentration, but they told us how they prepared that solution. So from this data, we have to find the concentration of calcium hydroxide. We know the formula, right? Basically, we have to find the molarity. What is the molarity? What is the expression for molarity? Number of moles of solute divided by volume of the solution in liters. What is number of moles? Weight of solute divided by molecular weight of solute divided by volume of the solution in liter. What is the weight of solute? It is 0.3 gram. And what is the molar mass of solute, which is calcium hydroxide? Please calculate. What is the atomic weight of calcium?
40, ma'am.
Atomic weight of oxygen is?
16 into 2, it is 32.
Very good. Hydrogen, it is 1, and we have 2 times of hydrogen, so 1 into 2. So please calculate the value of calcium hydroxide and substitute in place of M2. And what is the volume of the solution? It is 500 ml, and we have to express in terms of liter. So 500 into 10 power minus 3 liter. So from which we can calculate the concentration of calcium hydroxide, and we know each calcium hydroxide will release 2 moles of OH minus ion. So from which please calculate the value of pOH. From pOH, calculate the value of pH, and this is going to be a last question. First, tell me the molecular weight of calcium hydroxide.
$74, ma'am.
Okay. Marimuthu?
74, ma'am.
Okay, fine. Okay. Right. Now find the value of calcium hydroxide's concentration. Okay, we'll check Marimuthu. Okay, what was the concentration of calcium hydroxide? What will be the concentration of calcium hydroxide?
0.008, ma'am.
Very good. 0.008. So concentration of calcium hydroxide is 0.008 and each calcium hydroxide will release 2 moles of OH minus ion. So concentration of OH minus ion is 2 times of 0.008. So value is 0.016 molarity. So from which we have to calculate the value of POH, which is minus log of OH minus ion concentration. So I can write it as 16 into 10 power minus 3. And you can find the value of log 16 by writing it as 4 square. And we can find the value of log 2 also. So from which please calculate the value of POH.
1.791, ma'am.
Okay, 1.79. I can write it as 1.6. So this is POH. So what will be the value of pH?
14, ma'am.
No, it is not 14.
12.2, ma'am.
14 minus 1.8, right? So it is 12.2. So answer is option C. Marimuthu's answer was also option C, right?
Yes, ma'am.
Okay, very good, Marimuthu. Till now, you have any doubt? Tatvatika and Marimuthu?
No,
No,
ma'am.
ma'am.
Okay. So in next class also we'll be discussing few questions from ionic equilibrium. That is point number 1. See, we have completed volume 1 in 11th standard, right? In volume 1, the chapters are some basic concepts of chemistry, atomic structure, periodic classification of elements, chemical bonding, thermodynamics, and equilibrium. We have done with all the 6 chapters. As far as second volume is concerned, we have redox reaction, but I'm not going to discuss questions from redox reaction. While I'm taking electrochemistry, we'll be discussing questions from redox reaction. Okay, so we need not spend one separate session for redox reaction. That is very simple chapter. Another second volume chapters are general organic chemistry and hydrocarbon. But see, general organic chemistry is very, very, very important chapter. Without the fundamentals of organic chemistry, we cannot study the chapters in 12th standard. So I'm going to take general organic chemistry in depth. We are not going to revise the chapter. We're going to study the chapter. Okay. After which we'll be moving on to 12th standard. So, since we are starting with general organic chemistry, we'll continue to study organic chemistry of 12th standard. Okay. So, after general organic chemistry, we'll be concentrating on second volume chapters like haloalkane, halorine, alcohol, phenol, ether, aldehyde, ketone, carboxylic acid, and amines. After which, we'll be discussing questions or we'll be discussing concepts from first volume chapters like solution, chemical kinetics, and all that. Okay. So, till this point, we have done most of the chapters from 11th standard. Okay. Next class, we'll be discussing few questions from ionic equilibrium. From after that session, we'll be concentrating on organic chemistry. So, since we're going to start from organic chemistry of 12th standard, definitely we need the fundamentals. So, we're going to discuss general organic chemistry in depth. If we don't know any fundamental, we'll study there. Okay. After which we'll move on to organic chemistry chapters like haloalkane, halorine, alcohols, phenols, and all. After those 4 chapters, we'll move on to another physical chemistry chapters like solution, chemical kinetics, and all that. Is that flow okay? Is it okay, Tatvatika? Okay. Fine. So next class, please revise a few all the formulas from ionic equilibrium. We'll be discussing few more questions in ionic equilibrium. After which we'll be moving on to general organic chemistry. Okay. Fine. Okay, sir. Wind up பண்ணிக்கலாம், sir. Okay.